Ireland's focus has been on increasing the renewable content of our electricity supply, but we use almost 4 times as much energy for transport and heat than we use as electricity. However, if we electrify transport and heat, they will immediately become as renewable as the electricity that supplies them. And it gets even better. Thanks to the efficiency of electric vehicles and heat pumps, the energy requirement for transport and heat could be reduced by more than 2/3 when they use electricity instead of fossil fuels. This couldn't make more sense, and EU and Irish policymakers agree. However, Ireland's electricity system wasn't designed for these use cases. Will infrastructural upgrades alone make them possible, or will we have to rethink how we operate the electricity system itself? To find out, I'm talking with Ellen Diskin, Head of National Networks Local Connections Programme at ESB Networks, and Jon Sedgwick, one of my teammates at VIOTAS, where he manages our market operations strategy in Ireland and across our international operations. I'm Paddy Finn, and this is the Electricity Exchange. Jon, Ellen, we're here to talk about customer flexibility. So using electricity customers in a way that we can change this from being a one-way supply chain where the electricity system just supplies customers to being a two-way relationship where electricity customers interact with the power system. And this has been the focus of my professional career. So it's obviously a topic that's very important to me. So I'm really delighted to be getting to chat this through with you today. 2 people that I've had some amazing chats with over the years and really brought out a lot of colour on the topic, particularly when we're going through such a period of change. It's really important that we understand this and start to flesh out a lot of the challenges that lay ahead. And the power system is going through unprecedented change at the moment. So on one side, in terms of the supply of power onto the grid, we're trying to change that so we get 80% of it supplied by renewable energy and intermittent renewable energy at that. And then on the other side, the demands that are being placed on the power system by consumers are changing, not only in terms of the amount that they're consuming, but also the nature of the consumption, the time of the consumption, and also the lack of diversity. So it really now has become something that's changed from just being important in terms of my view and my professional career around this, but its importance is really being recognized as being critical to the future operation of the power system. So I'm really, first of all, I suppose, quite keen to draw out some of the points around the challenges that are faced by the integration of renewable energy. And what are those challenges and where demand response and flexibility play a role?
I can jump in and shed some first thoughts on that. So, fundamentally, we're moving from a system that's been dominated by, conventional power generation stations, which are, first of all, dispatchable. There's no intermittency there. So we're moving from a system dominated by kind of dispatchable, controllable plants to one where we've got huge swathes of intermittent power generation on the system. We have to be able to cope with the periods where the wind doesn't blow. On the other side, we're moving from the system where the conventional power stations provided a kind of whole host of characteristics to the system that made it inherently very, very stable. So they were providing inertia to the system and other kind of reactive power and fault resistance and things like that. So we're moving to a world where we've got lots and lots of renewables which are non-synchronous technologies, and so they need to be complemented by other measures on the system to ensure that the system has the inertia and the ability to to ride through various faults that can happen on the system and stay stable and resilient. So we really see, we need to complement those renewables to enable us to get to the penetrations of renewables that we need to meet our climate action plan targets. We need a suite of other technologies on the system, be that batteries, synchronous condensers, and demand flexibility that can complement the renewables and ensure that that the system remains as stable and resilient as it was in the past, with a completely different kind of portfolio of technologies.
So I suppose what we see is that we've really, I suppose, to date, the operation of the power system was fundamentally based around characteristics that were implicit with thermal power plants, and we took those characteristics for granted in terms of the not only their reliability but their consistency of delivery, the inertia of the power plants as we talk about in that. And when we replace that with renewable energy, it's replacing one facet and we have to supplement it with others. And I suppose a lot of the technologies that are often looked towards are very expensive solutions in terms of bringing in additional battery storage onto the system, synchronous condensers, continuing to maintain the generating fleet as well on the system. And I guess we've seen that, demand response and customer flexibility can deliver a lot of those services.
Yeah, I think it's fascinating. So my current role is focused on market design, and as we're kind of as markets globally are moving away from all of those nice characteristics that conventional power plants provided naturally as a kind of inherent byproduct, systems and markets worldwide are looking at saying, okay, we need to be able to actually define those different characteristics that the system has become reliant on and explicitly value those so we can find other technologies to meet them. So looking at, okay, what inertia does the system need? What kind of fast response services does the system need? What reactive power capabilities does the system need? And creating markets so that the new technologies that can provide those can be brought to bear, and investors can bring those projects forwards to complement renewables.
Yeah, and the way I've kind of visualized a lot of those services is around, I always picture the system like a seesaw, and that we have electricity customers on one side and we have generation on the other. And if you've got a perfectly balanced seesaw, even if there's 1,000 tons on one side, on each side, if it's perfectly balanced and you put so much as a pebble on one side, it just tips. And where we've had thermal plant on the system, what it's effectively done is it's given us big springs on that generation side, big springs like the dampers in cars, that like the springs in cars, that ultimately help to slow the reaction, that allow us to actually, operate the power system. If there's a problem or changes on one side or the other, we have time to counteract those problems. And whereas I think what a lot of people don't realize is that we still need to have some of that spring until we find alternate sources of quick response, for example, that can step in very quickly. You need to have that spring effect. So as you increase the amount of renewable energy, which doesn't give that whatsoever in terms of like wind and solar, you're taking away the thermal power plants that are giving you that effect, that inertia, that spring effect. But you need to, because you need to have some of it, it places a ceiling on the amount of renewable energy that the power system can actually use, because you have to maintain this. So the more we help to replace those characteristics from thermal power stations with other technologies that can sit in the background ready to step in, the less of that spring we need from the thermal power plants, and the more we raise the ceiling on the amount of renewable energy that can actually be usefully used on the system. And, so I think that it's not only a fascinating area, but it's one that I think is very seldom understood. People think that intermittency is the major issue, whereas there's clearly other facets that need to be addressed. And when we look at the distribution system, so how the power is ultimately delivered to our homes and businesses. So we have the transmission system, the arteries, the highways that get the power to major points in the country. The distribution system, that's the real capillaries of getting it right down there and into the local areas. And what we're looking for it to do for us now, in terms of as we look to electrify transport and heat and increase demand in parts of the system, and change the characteristics in terms of how people use power, we're really asking questions of it that it just wasn't designed for. Those purposes weren't there. So the use case for the distribution system going forward isn't the use case it was designed for. So what's gotten us to where we are really doesn't get us to where we're going, or does it?
It will. But look, to understand the nature of the change in what we're asking it to do, I think you have to go back and say, well, where did our electricity network infrastructure come from? So go back 100 years. 100 years ago, a tiny, tiny fraction of Irish households and businesses had electricity, and they were run by these little town utilities. And then roughly a year ago, little less than a year ago, Irish State came along, ESB was established, the Shannon scheme. So we went and we built this hydroelectric scheme, which was at the time, I think, world leading. And we built out at that point what was then a transmission network. So this 38 kV network around the country. That's actually now part of the distribution network. And those original stations and circuits, they're actually still out there today. You bring it on a few decades to the 40s through the 60s and you got rural electrification. So at that point we said, right, we are going to get electricity to every single home and farm and community in this country. We are going to drive social and economic development. So that was done, and that's absolutely brilliant. But the network that was put up at that point, that is effectively the infrastructure we've got today. And I mean, over the decades, absolutely, we've renewed it. So naturally, say in the 90s to early 2000s, we replaced an awful lot of the original wires, the original headgear, to make sure that we had a network infrastructure that was reliable enough for the 20th century. And of course, there was expansion. So as Irish society expanded, our towns got bigger, our cities got bigger. Even across the countryside, we had more and more homes, more and more businesses. We've extended the network. But we've never actually had to go in root and branch and start, doing surgery to expand those wires from a local level. It's always been extend, not expand. And that means that how we've designed the network, we've accounted for behaviors. So for businesses, we design for their peak demand. But for domestic customers, we've always designed based on behaviors. So things like, we know that not everyone uses the shower at the same time. That's one of the big loads in your home. People don't necessarily have dinner at the same time. So the design standards that worked when they were building networks back in the 40s and 50s and 60s, the network of my grandmother, that network has been absolutely fine for my mother's generation, for my generation. So back in the 50s, people's lifestyles were a bit more similar, but there were so many fewer big loads in the home. It really was just maybe the kettle, the cooker, if you were lucky, a telly. When it came to the 90s and 2000s, yeah, there were bigger loads, so there were electric showers, but more diversity between people's behaviors. People don't take their 7-minute shower at exactly the same time. So the design standards that worked through the generations, from my grandmother through to my generation, they're absolutely fine. They have done the job. And I suppose really the philosophy of system development has been lean. It has been lean, economical. Let's get enough there to support society. The thing is, I mentioned it's not going to support the next generation. Well, sorry, it is going to support the next generation, but it needs more. See, climate action over the last number of decades has really changed things. And I think the Climate Action Plan of 2019, that's the one that said, right, we're going to now get down at the most local level and change how we use energy. We're going to finish off the job we've started. So we are world leading in wind generation. We are now going to go right up to 80% average of our electricity coming from wind generation and solar generation. And then we're going to take that wind and that solar and we are going to use them to power our cars and to heat our homes. Now, what that means in terms of demand on the system, it means that the average Irish home goes from where it is today. So 25% of your energy comes from electricity and the other 75% is your heating oil, your heating gas, your diesel. So the other 75% is fossil fuels. We're going to take that and within a decade or so, we're going to go to half or more of our homes being 100% electric. So what that means in terms of the infrastructural needs as well as those dynamics in the system is absolutely enormous. Now, the strategy, it is really, really smart. So it uses what we have. It uses this wind resource that we have in abundance in Ireland. It uses the network infrastructure, which again, it's one of those few infrastructures that already touches every single home and business, which, think other infrastructures, telecoms to a degree. Internet, no, it doesn't reach every single one of them yet, or not the way it could and should. Gas certainly doesn't. So it is one of those few infrastructures that reaches every single home and business. We are going to leverage it, but we do need solutions to ensure that the network can support this change in capacity. I suppose the strategy, it's not just building, so reinforcing, upgrading, that is an important part of the solution, but it's not the whole solution. A balanced mix of reinforcing and also electricity demand flexibility. That's the strategy. I mean, think about any other infrastructure. With the roadways, when we got more traffic, we don't just infinitely widen the roads. We put up traffic lights. We give people Google Maps and we give them the information so that they can manage things themselves. Or even with telecoms and internet, we don't just put out more copper wires. We move to fiber. We move to multiplexers. We put in place the technology that allows us to manage the traffic. So now that's what we want to do. We want to do it partly because it's the right thing to do and it's the smart thing to do, and it allows us prioritize where we do the reinforcement and manage supply chain, manage the pressure that is going to come on over the next number of years. But it also, I suppose, it focuses on the actual objective here. the objective isn't get renewable generation onto the system. It's get renewable energy consumed up to 80%. It's about getting people using that renewable energy when it's available, where it's available, making the most of that resource that we've got. So flexibility, it is such an important part of the solution, but you're right, we can't understate the change this is going to mean for our electricity system.
I think this is, when you talked about how the system was designed in the past and how we're looking to design the changes to the system, the design in the past wasn't flawed in any regard. Both design philosophies are trying to maximize the characteristics that are inherent in the consumption that's there. So historically, we've had considerable diversity. So if the power system had been built to assume that everybody is using the maximum amount of power at all times, we would have vast, costly redundancy in the power system that's just remaining underutilized. And that wouldn't be an efficient approach. And I suppose as we look forward to the next stage, it's also, again, re-looking at what are the inherent characteristics of what are there. And when we look at the makeup of customers, particularly on the kind of lower tiers of the distribution system around your residential and commercial, I think Ireland has been different from a lot of countries in that we haven't had great flexibility in the types of loads that are there. So other countries would certainly have benefited from having air conditioning, etc., which will be contributing to peak, but would also be part of the solution. You can be flexible. People can turn off their air conditioning for short periods of time. Whereas our peak in Ireland, I guess, would have been really driven by, people coming home in the evening, and it's really what they are doing is very essential to them. It's essential to their lives. They can't stop it. But now this change is that the challenge that we're facing is for the consumption of the renewable energy. We're looking to bring bring transport and heat over to use electricity rather than fossil fuels, which has multiple benefits because electric cars and heat pumps are far more efficient than their fossil fuel equivalents. I think you can get more than 3x increase in efficiency. And while it's increasing the load, it's also giving you the types of loads that actually help the power system to be flexible. So you can change the timing of your electric car charging. You can change turn off your heat pump for a little while, right?
Yeah. Oh no, you're absolutely right. So first off, on the standards haven't been wrong. Really fascinating one. About a little over a decade ago, there was a pilot of smart metering rollout in Ireland to get the initial technology systems right, understand what behavioural change can be scared. But with that data, we actually did an awful lot of analysis to test, are our assumptions about diversity correct? And we took all of the data, so there were several thousand customers, and just took that together and said, on average, are the diversity factors that we've accounted for in our designs actually being borne out? And they were. It was really fascinating to see that this assumption we've been working on for decades absolutely held up. But on how we've got more flexible load coming, so heating and transport in particular, they can be part of the solution. You said that in Ireland, our demand, I suppose it follows our behaviour. So it follows when you get home and turn on the cooker. It's actually fascinating, again, to look at demand profiles and how they've changed over the ages. So going back to my grand's household versus my household, in hers, it would have been 0, 0, 0, 0 all day with a little bit of the ironing coming on, a little bit of whatever else. And then in the evening, up we go for cooker for dinner. So the family dinner's had as my granddad and my mum and my aunt arrive in, and then things drop off in the evening, except for the lighting until everyone's in bed and then gone. And then it comes to my generation and we have to get up that bit earlier to commute into city. So you've got this blip early in the morning and then down, and then you've got a more gradual peak up and then peaks that are later because, so say out around North County Dublin, you can see there's a peak around 7:30 in the evening, and the further out you are from the city, the little bit further out you've got the peak in the evening. So it's absolutely fascinating to look at. But with electric transport and electric heating coming in, that changes. So recently, one of my favorite things to do, this is a bit sad, but I like going into the control room, looking at the systems, picking out my area and seeing what does demand look like in my area. So recently I was looking at it and saying, okay, right, so there's where our peak is and there's how much lower we are at the weekend. You can see a lot about my community by looking at our electricity demand. But then I had my team overlay electric heating patterns on top of that. So we took, electric charging patterns. So we took the car charging patterns. We took ones which we had recorded from the UK, and we also took ones from Dingle, so a Dingle project run by ESB Networks. And we overlaid them on underlying behavior in my area and said, look, based on our expected uptake in my area, what does it look like? And suddenly this, up in the morning, down for the afternoon, up in the evening and down turns into loads and loads and loads of load overnight, down to the morning, up a little bit to the evening, down as people go to bed, and then up overnight. It was absolutely fascinating. And it just shows even in those early uptakes, say in Dingle or in the UK, people do charge at night. There is so much ability there to move things around. I never thought I would look at a middle of the night peak, but what I was looking at was daytime load in my area being swamped by charging overnight. So what we need to do now is start working with people to shift behaviors or manage behaviors or get the technology in that supports people to manage their behaviors before habits are formed. Let's start forming the right habits and getting the right technology in from the outset. So we don't need to change something. We've got a system that works from the outset. And I mean, Paddy, you've been talking about this, it becoming more interactive between demand, the customer and generation. Honestly, to me, it's more, this is about the customer taking control. I am going to take control of how and when I use electricity. I'm going to put in place the technology that supports me in doing that, because I don't want to just be a receiver of renewable energy. I want to be consciously driving down my own carbon footprint and my costs by charging and using that electricity when it's available, when it's local, when it's renewable.
I think a very interesting point out of all of this is about extracting what's there, and making customers a real part of the story, and taking the characteristics that we know exist and they're changing characteristics and using them as part of the operation of the system. And I think when we look at larger scale customers now with the transmission system problems, so we know that there's big constraints in the power system. We know that there's constraints in the Dublin area. And as the power system changes to bring on more renewables and transporting it largely a lot from the west of Ireland to that region is going to be a real mountain to climb. We need to supplement the characteristics we spoke about earlier on. But now we see that there's huge demand from data centers. And this has been very keen in the public eye over the last months and years as the message has gone out that the power system is operating at its absolute limit. So what types of traits are they bringing to the system in terms of the challenges that they're creating, but also what's the potential there for, we've spoken about down at the commercial and residential level in terms of what we feel can be done there, the challenges that need to be addressed. But now we go right to the opposite end of the system. And you're looking at the data centers that are coming online, consuming more power, but also providing services that are critically needed, electrifying them in Ireland, where we have an increasing renewable content in our power system is far better than operating them in other countries. We're dealing with a global problem here. But when we look at their characteristics, can you give us an idea of what challenges they present to the system, but also what are their inherent characteristics that we can try to extract the benefit of the operation of the grid?
Absolutely. I can certainly try. So at the kind of transmission system level, at the wholesale level, there are already kind of various programs in place to provide signals to large industrial and commercial customers to bring to bear the flexibility they have on the demand side, whether that's bringing on-site generation, adjusting their consumption profiles, or even providing very fast response services in response to frequency events on the grid. And companies like VIOTAS, we're a demand response aggregator. We're acting as a conduit to enable customers to respond to those signals on the grid to deploy the flexibility that's inherent within their sites and within their assets. So demand response aggregators, within Ireland are already making available, several hundred megawatts most of the time, that's there to support the grid. Data centers are, a good example of a large industrial customer that has exactly the kind of capabilities that the system needs. Most data centers have uninterruptible power supply systems, large batteries that enable them to ride through being disconnected from the grid or without any of their systems going down. Those systems are exactly like, the large batteries that are being deployed around the island to provide the very fast response services needed to complement renewables. A lot of data centers also have backup generation systems that can run for several hours. Again, that can provide the sort of backup capacity that's needed on the grid when we have that confluence of low wind at the same time as we have winter evening peak, and making sure that we have enough capacity to meet demand. So data centers exactly have the type of inherent flexibility that if they're willing and able to bring it to bear, can support the system.
And the type of flexibility that they can offer is flexibility that helps to support the reason they're here, right? In terms of the renewable percentage in our system is good, but needs to increase. And data centers have a lot of the storage systems, the backup power systems that we're actually looking then to separately build in order to enable the power system to use more renewable energy. It already exists. And, when we look at building new, for example, open cycle gas turbines, I think one thing that we often forget about is the carbon associated with building it in the first place. We always think about the carbon associated with its use phase. So I think there's a negative perception towards the idea of using diesel generators, embedded diesel generators, in order to provide support to the system. But when you look at what's needed from a peak demand point of view, it's only a small number of quite a small number of hours per year where we hit that last 200 megawatts of peak, for example. And, we looked at it together and saw that if you build an open cycle gas turbine, it's about 200 megawatts, it's about 120 million euros plus 100,000 tons of carbon or thereabouts before you ever turn the key in it. Whereas you have these diesel resources, for example, sitting there. And if you use the diesel generators, I think, John, you worked out it was a considerable period of time that we could use them for.
I think we worked out that, you could run those diesel generators for in the region of 50 hours a year for more than 40 years before a kind of state-of-the-art open cycle gas turbine burning natural gas had effectively made more sense from a carbon perspective, accounting for the build phase.
That's incredible. And when we then look at using alternative fuels, there's, I think historically with biofuels, there was a challenge with biofuels that they had an expiration date, a kind of quite a near expiration date. So are there options available to us from a biofuel point of view to even extend that period of time that we could actually run the diesel generators for and still be beneficial?
Absolutely. And that's something, VIOTAS is working on at the moment with a number of our customers is using, green fuels. An example of one is called HVO, hydrogenated vegetable oil. And it's a kind of renewable, it's derived from waste cooking oils and fats. And it's, can deliver roughly a 90% reduction in CO2 versus mineral diesel. And it's a kind of drop-in replacement. So where you've got existing assets burning diesel, it's a really valuable solution. I'd like to go back a step, actually. So one of the things I was really fascinated by, most of my work at VIOTAS is within large industrial and commercial customers, kind of at the wholesale level. We went to Dingle a few months ago. Some of your colleagues, Ellen, facilitated a visit. And one of the things that I think you're the same, Paddy, I can't get out of my head is the diversity design characteristics that are built into the system. I remember that we went to visit a household and it was one of 6 households connected onto a single kind of 15 kVA transformer. And if you do the maths on that, you kind of quite quickly realize that, when you start installing kind of 7 kilowatt EV chargers and things, once there's, any more than 2 cars within that neighborhood, the whole design kind of philosophy of the network starts to break down. I think I couldn't, it's absolutely fascinating, the kind of the difference in approach that we're going to need when we really go from the kind of wholesale industrial commercial zone where our focus is now down to, the approach we'll need to really get into the capillaries. Fascinating.
And what you saw down there in Dingle, that's entirely normal. So nearly half of Irish customers are connected in groups of, say, 3 to 6 or 7 to those 15 kVA substations. So you're right. 2 neighbours have an electric car. If they're charging at the same time, you're kind of hoping nobody else boils a kettle. that is normal. And that's why it's really, really important that we're able to start introducing flexibility right down through the voltages. And I mean, it's great what's been achieved up at an industrial level. But look, in reality, about 10% of our peak demand comes from customers at 110 kV and 38 kV. So if we are serious about achieving our targets on this system, we are going to need to start getting right down through small commercial and domestic customers. And it isn't a lift and shift. So with those industrial customers, they have the facility, they have the financial facilities, they're used to doing cost benefit analysis. It is relatively easy to put in the infrastructure that you need behind the meter to be able to do this. And I mean, that's great. Again, we want to promote it. So we're looking at new tools like self-assessment. So that someone who is considering developing a new industrial facility has the information to identify, okay, how much revenue am I likely to make over time if I put in, say, the storage facility behind the meter, or I put in whatever else. But if you bring it down the voltages, so small commercial customers or smaller commercial customers, Ireland is a nation of smaller companies. About 50% of our peak demand actually comes from smaller business customers. And they're so diverse. So a farm is not the same as a factory, is not the same as someone who's in the customer services industry. And with those, so some of them are ready to go with this. Again, you spoke about the existing demand side flexibility market. About 48% of what's there today is hotels, supermarkets, and food facilities. So there are some industries that are ready to go. And there are other industries who are saying, oh, hold up, wait a second, not quite ready. The thing is, our program, National Network Local Connections, it was actually inspired originally by small businesses and coming from two different angles. One of them is a number of years ago, we were doing a roadshow around the country as we were developing investment plans. And we wanted to probe into customers' interest in becoming more flexible, playing a role. And at one of these, it was a breakfast meeting. I remember there was a local business owner who said, look, have you got information about what's going on in the system? I know that there's a wind farm near me. Can you show me that when the electricity is greener? And we said, yes, absolutely. Sure. We're monitoring all of that from the control room all of the time. He said, well, could you push it out? I would like to put a screen up behind me in the shop to show people and to show them when I install something, I'm contributing, and to show them when I'm shifting my behavior, I'm shifting to those green periods. I mean, the other thing is I used to work in operations in and around the control room. And I remember there'd be times in winter when you needed to take out a piece of plant because you were completing connection works for a new generator or because there was a fault that needed to be fixed. And you'd get to a point in the evening between 6 and 7:30 where you kept a very close eye on demand in particular parts of the network. And I remember I used to get onto the local supervisor and I'd say, look, are there any factories around you could go into and just talk to them about maybe not doing a production run on a given evening, and hoping that there were just those few megawatts we could get out. And we generally could, that made it possible for us to take those outages. So small business at that medium and larger connections at low voltage, they are going to be so much of this, but they need support. Recently, we tried to buy demand side flexibility in a number of locations around the country. And of 8 locations we went to, only 5 of them had customers who were actually willing to receive a payment to shift their demand. And of them, it was typically in the locations where there were industrial customers. So for those smaller businesses, what we want to do is start getting out and matchmaking. We want to bring together businesses, so aggregators like VIOTAS, some of the suppliers, with businesses out in the areas. So, those shops, those farms, and we want to bring you together and, give the support, the information, the expertise that you have, and bring that to the businesses who we're going to need to participate in this, because they do need support. They need information. But then you go down that level again. So to the people in Dingle, to the people in Donabate, in Marino, in Clare, you go to the customers everywhere. Out of the 2.4 million connections to the electricity network in Ireland, 2.1 million of them are households. They're the people connected to those 15 kVA substations. For domestic customers, so they contribute about 40% of peak demand. So they have to be part of the solution. And again, every one of us, we all want to on some level. We want to because we want to leave something better behind for our kids. We want to because we want to take control. We want to choose, yes, I'm going green through my actions. But we've done a lot of research to understand, well, are they aware of this as an opportunity, and are they motivated to go with it? What barriers do they see? First of all, no, nobody who doesn't work in our little bubble really knows about this. People haven't thought about it. They're not aware of what renewables there are or aren't on the system. They're not aware that, look, at certain times, it could be 75% from the wind, those electrons coming into your home, and at other times it could be almost zero. They just don't know. They are motivated to do this. Once it's explained, it's pretty easy to get. So, we've had focus groups where you've got someone who's got an electric car and they'll say, oh God, I didn't know that plugging in at different times had a different impact. I didn't know that I could be driving on fully renewable energy if I just knew the right time to plug in. So it is easy to grasp and people want to do it because, again, inherently, we want to leave something better behind, but we need to understand what works for different people. So what works for younger people who are focusing on getting onto the property ladder, getting into a career is really different from what works for someone who is, say, in their 50s or 60s, who's beginning to step back from work, who's got grandchildren running around. It is different and we have to understand it. We also have to understand the mindset in this country versus mindsets in other countries where this has worked. So in Ireland, we care about my property, my land. There are studies that show when you compare, say, Irish people to German people to American people, whereas for German people, the economy and green, they're much more important than my personal property. For people in the States, it is all about the economy. In Ireland, so much of it is about my property and my kids and grandkids as an extension of that. So again, we need to understand and work with that. But in terms of the barriers, so the big barriers people see, one, information. I don't know about this. And even if I knew about it, who's going to give me support? And then ease. Even if I know about it, is it as easy as going into Power City and getting the right washing machine? I don't know. Am I really going to put in that much homework? Again, there are studies that show for most people in Ireland, the decision of what heating system I get next, it's made by their plumber for them. And then finally, cost. So again, we need to bring together some joined up thinking on this because today, some of the technologies needed, they are more expensive, but we need to work together. So things like standardization so that the smarter technology comes down in cost and it is the standard technology, and also grant funding. So again, adopting the technology that future-proofs you is also adopting a technology that's affordable. We need to start addressing those barriers. Otherwise, that 40% of peak demand, that's domestic customers, they're not going to get the opportunity, and we need them getting that opportunity.
When we look at, the example that we spoke about in Dingle, it absolutely shocked me to think that every home on paper has a 12 kVA, roughly 12 kilowatt import capacity that they're supposed to be able to use. Yet in a neighborhood, if they were to all use it, we spoke earlier about the optimal design of the system, assuming diversity, not everyone does something at the same time. But I certainly would have expected there to be some more overhead than there was. So, 6 homes supplied from a 15 kVA transformer. So instead of the hypothetical 72, you have 15. It sounds like this is representative of a large mass of the housing stock, and that in terms of the infrastructural upgrades, we can't bring them all up to the 72. So it needs a combined solution, which we've been talking about, between flexibility and infrastructure. But I guess a lot of, you're talking about the customer sentiment to provide in services. And a lot of that is, it's implicit demand response, where you're appealing to the goodwill of customers who have an emotional tie to to increasing percentage of renewables, etc. Then we have price responsive customers, where we now are on the cusp of national smart metering, and they can have half hourly pricing potentially that will give them financial incentives, and they may or may not move. And I guess that implicit demand response, it reduces the types of peaks that we're going to tend to see, etc. But it doesn't give us a firm tool that really allows a power system operator to hit a button and know this is going to be the outcome. And I think that this is where what's about to happen on the distribution system and the types of flexibility services that we are looking for, that are being sought after, can certainly learn from what's been achieved in terms of the explicit demand response that has been a part of the transmission system operator now for a decade or more, and where there's hundreds of megawatts of industrial customers who make their loads available to be reduced, loads where the reduction won't have a significant negative impact on their businesses. And in something that sounds so simple, it sounds like they're making a load available to be used. it actually represents a lot of different characteristics. And I think, Jon, you've seen the evolution of it going through the different types of services. And I suppose, where you've heavily worked on is actually, like, parts of our team have worked on the innovation, the developing of the technology that allows certain characteristics to be extracted from our customers, and you've very heavily worked on paving the regulatory path and regulatory changes, working on regulatory changes to try to enable it in the market and create incentives for our customers. But what does that range of characteristics look like? It's not just I'm available to reduce my demand. That actually represents a lot more than meets the eye.
I think what you mentioned there is a really interesting point around the difference between implicit demand response and explicit demand response. Implicit demand response, if an industrial customer is looking at the wind forecast for tonight or looking at the power price for tonight and saying, hey, I'm planning not to run my 5 megawatt process. I'm going to reduce my load by 5 megawatts. The system operator doesn't have certainty that he's going to do that. So the system operator needs to plan, he needs to plan to see what if the demand might be 5 megawatts higher, it might be 5 megawatts lower, that there's a kind of degree of uncertainty, and that all has to be factored into their planning. Whereas explicit demand response is actually the industrial customer kind of saying to the TSO, the system operator, I'm here, I'm available, I have 5 megawatts of my load, which I can turn off on your demand. And it becomes like much more predictable and controllable and usable by the system operator. And I think there's real value in that. And that's at the industrial and commercial level. That's really what VIOTAS is focusing on at the moment, is, taking the inherent flexibility within those industrial and commercial assets and making it not only an active participator in the market, but an active explicit participator. So making its capabilities, reliable, controllable, and visible to the transmission system operator. And I think it's really important. Probably what we need when we get down to the residential level is a mix of both. But I think it certainly needs to be a kind of key factor in how we design the markets for flexibility, is, recognizing there's extra value in that explicit flexibility.
Just to echo that, they are different things. They both add value, but from a system operator perspective, their value is very, very different. I mean, system operators, we're in a very long-term business. We're here for generations. We invest for generations. When we do things, we like to do them with a degree of certainty. We need to do them with a great degree of certainty, because nobody's going to thank us if the lights go out. Our job is to get the lights on and keep the lights on. So, I mean, we've seen for quite a while now what is coming down the road in terms of managing demand, in terms of the demands placed on the system. We undertook a number of studies a number of years back to just see, well, what kinds of investments in the infrastructure are we going to need to make? And what we identified is to support the electrification of heat and transport, and to support the adoption of renewables right down to a domestic level, we're going to need to increase investment in that most local level by 5 to 6 billion euro, which is quite a step up. But we also identified is that with flexibility, we can bring that down by €1.5 billion or so. So that's quite significant. And again, this is societally funded, so we want to bring it down. But the thing is, to do that, that's not based on the implicit behaviours, which again, we do want to achieve. It's based on the explicit behaviours. When I am in the control room and I'm deciding whether or not I can set up the system a certain way, whether or not I can take out a piece of plant, I need to do it with certainty that when I call for a specific response, I'm going to get that specific response. What I would caution is, though, we were saying there, we need to take what we've applied at the transmission level and bring it down. At transmission, the customers who are connected at that level, this is about contracts and commercials. When you bring it down to small businesses, sole traders and domestic, it starts being about lives and livelihoods. So we do need to take a range of approaches, not just lift and shift from transmission.
Absolutely. Sorry to come in, Paddy. I think you're absolutely right. Within VIOTAS, we have a portfolio of demand response assets in the Irish market, in excess of 180 megawatts, and that they're all fairly large. I think the smallest customer we have is still around 200 kilowatts, and they range right up to approaching 20 megawatts. Within the industrial commercial space, we have to explicitly register each of those customers with the transmission system operator in order to provide demand response. We have to go through a comprehensive testing process under the grid code, and to prove the site's capability to provide different services. We have to install, expensive kind of metering and control equipment so that we can provide the system operator with signals in real time letting them know exactly what the capability we have to provide different services is. And, that approach is brilliant for industrial and commercial customers, but you're absolutely right. It won't, it can't be kind of picked up and dropped down on. It won't work for residential.
Another point with explicit demand response, though, that I think is often missed is, well, the power system can't just work perfectly most of the time. It has to work perfectly all of the time. And when you look at implicit demand response, you are continually taking actions and you get paid based on the action that you've taken. Whereas explicit demand response, which means that you have said that you are available to do something and you can be called upon to do it, there you have a value for just being available, not when it's actually just activated, but for being available. And I always think about it like having a monitored alarm in your house. It's not only of value every time you get burgled, it's of value to you all of the time because it allows you to keep valuables in your house in the same way as when the distribution system operator and transmission system operator have these services available to them. They know they can run the power system in ways that are made possible because they can rely upon these stepping in. And I think for customers, it's important to understand that this exists, that the ability to do something has a value. And I suppose when we look at over time, the characteristics of demand response in Ireland and flexibility have changed. And people who kind of look past just price response and they think about explicitly, they first think about peak reduction and its value. And you're being dispatched, you have an hour's notice or so. And then we then would have a very significant portfolio of customers that can actually increase their demand. So that's when there is high levels of renewables on the system that would otherwise be curtailed. And our customers can increase their demand through the use of increasing the demand by processes, or even some customers who would use their own embedded generation most of the time through gas generation. They'll shut that off and absorb from the grid and allow the power system to use more energy. And then I suppose we were very focused in VIOTAS in developing very high-speed technology. When we entered the market, we set the pace at what we had 1 second metering, and the requirement was 15 seconds, and we were beating it with one. And then we went firmly down the technology route, and we have our systems that we design internally now. We monitor up to 8,000 times a second, and the view that gives us of the system is very powerful for understanding the effects of what's going on the grid. It also allows very, very fast response. So if a power station, we talked earlier on about that spring, the springiness and the seesaw, and that you need to have quick response. The more quick response you have, the more you can reduce the spring. And if a power station were to trip in County Cork and we were controlling, for example, the kilns in a cement factory, which could be several megawatts, and this will be across multiple sites, multiple megawatts available. The time from when the power station trips to when that load is at zero is a fraction of the time it takes you to blink your eye. That's how quick it is. And so we've seen the evolution through peak reduction services, demand, so curtailment reduction services, frequency response, and we're going to continue it more. But when you look at like frequency response, that could be responding to voltage, for example. So I suppose, it's interesting now that we're starting to see, I think our last decade, Jon, has been focused on services for the transmission system, the heartbeat of the system. But now we're really, over the next decade, for us, we see that the opportunity is now with the distribution system.
I think that's absolutely right. We've seen, here in Ireland, it's often talked around that because we've got quite a small system and it's quite weakly interconnected to the system in GB, and we've managed. EirGrid have done a lot of work to push up to be able to accommodate up to 75% wind in any given interval. We've started to see some of those challenges before other markets. So we see other markets globally at the transmission system level now kind of looking for those faster response services that that VIOTAS and other companies have kind of really pioneered here in the Irish market. But you're absolutely right. I think that there's massive opportunity to get down to those capillaries, and as we look to electrify massive swathes of of energy, which has kind of previously been supplied via a network of petrol stations and via the gas network and tankers taking around heating oil to people's houses. As we put all of that onto swamping the distribution network, there's huge opportunity there to deploy that flexibility.
And if you want to see just how much, when and where, it's all available on our website. So we've been analysing this. Go to National Network Local Connections on the internet. We've got a document called the 2030 Power System Requirements, and it sets out area by area what kind of flexibility requirements are going to arise. And it's not just managing demand. Paddy, you mentioned that idea of shifting our usage or shifting our storage to the periods when the wind is blowing or the sun is shining. That's an awful lot of it. I used to, again, one of the things I liked doing in the control room was looking at what areas are actually net exporters. And Donegal, oh my gosh, Donegal was a net exporter so much of the time. It was just a little generator up there. The thing is, when we look out 10 years, we've got this graph, I think it's in that document, where we set out area by area, roughly a county level, which areas are going to be net consumers of electricity and which are going to be net exporters of electricity at peak demand. So I'm not talking about summer valleys, I'm not talking about low load, I'm talking about at peak demand. And at peak demand, Dublin, Cork, Limerick, maybe Galway, they are still net consumers of electricity. But everywhere else, there's this sort of graph, and I call it the Tullamore to Tralee graph. In reality, it's Tullamore to Tralee in a graph. It includes pretty much all of rural Ireland. They are net exporters. And that's great. The thing is, we don't have transmission capacity to take infinite oversupply onto it. So the more that we can consume and store that energy at a more local level where it's being generated, the more, again, we can make use of that indigenous resource. We're not going to need to constrain it off. And that constraint off, it's been a transmission issue to date. Increasingly now, it's going to be a reality at distribution as well. I mean, it's going to be a reality because we want to accommodate all of that generation. It's really valuable. It is really important. But again, to accommodate it on the system, we need to start being able to get people to take control and choose to shift their storage or the usage to those periods when the wind farm down the road or the solar panels up and down the street are going full tilt.
We also need greater insight into what's happening in real time because, like, to date, a challenge that we faced is that on the distribution system, and we would have customers that are operating on the distribution system exactly where you want to affect change, and they're generating. And but a challenge for us has been that because the distribution system operator doesn't have real time signals from some of those parts of the system, and that's changing now, and that's indeed changing now. That the rules that were imposed were almost based on rules of thumb. It was the August bank holiday weekend taken as being lowest demand, and I'm sure 21st of December is peak demand, and if it has to basically tolerate operating on those two, and then it's okay. But clearly that doesn't expose a lot of the potential to operate the rest of the time.
And okay, so to clarify, we do have the signals coming back from everywhere in the country in the distribution system. The things that we don't have, well, first of all, we're not pushing that information outwards. So you can see all of it, again, go into the NDCC and suddenly the entire country is there. It's living, it's breathing, it's fascinating to look at. So we're getting all of the data in, but we're not pushing outwards, okay, here are the times when you should be shifting. Here's what's happening on your local system. Here's how you could contribute. Here's how you could profit from doing so. But the other thing we haven't had, say, forecasting capabilities and optimization capabilities. So yeah, we can see when peaks are happening and valleys are happening. What we can't do is predict, or we couldn't do particularly well. And when you can't predict, you can't really manage to it. So we're starting to introduce those forecasting facilities, optimization facilities. We've got them going live in the control room from July, August this year, so that we can start going live on a number of flexibility schemes from this October. And then every 3 to 6 months from this October onwards, we're going to be going live on new schemes, again, using those new facilities. So forecasting, optimization, ability to send out signals, also ability to monitor what changes happened, to settle that. So we're starting to have those facilities. So again, we can provide more visibility out there, and we can also use that and reward that.
And this is a huge period of transformation, clearly. And we've spoken about what it takes for us to enable one of our customers in terms of the testing requirements, the technology requirements and everything, and it's huge. And whereas a lot of the principles of what we have achieved in terms of, there's hundreds of megawatts of electricity customers providing services into the transmission system, and it's almost enshrined in the electricity market in the electricity market operation. A DSU is part, it's like a generator, seen in the electricity market like a generator. But whereas we can lean on the principles of what have been achieved and some of the technical outcomes of what we've done, the solution really doesn't transpose down. So, Jon, just kind of keen to get your view on, with the residential sector, it's probably not very economic for us to start rolling out the same type of technology that we roll out to the industrial sector. So what kind of different approach do you think we need to take to actually enable the residential sector?
It's a good question. I think it ultimately has to be cheap. And I think it has to be easy, so it needs to be highly automated. And I think it needs to be kind of, we talked about it earlier, it needs to be built into devices. So the devices which have the large loads, the EV chargers, the heat pumps, the fridges, these devices that they need to kind of be inherently smart and flexible.
So it's almost a case that whereas we enable it with our clients, it needs to be enabled by the technologies that customers are already buying. But for those technologies to bring that type of capability to bear, there needs to be a market around it. There needs to be standards. There needs to be incentives. So what work is ongoing to actually put that in place? And if it's a case that, you build it and they will come is the approach. What's your view on that? Is that the suitable approach?
Yep. So first of all, I couldn't agree more that you need the standards to be out there. So over the last year, we've invested a lot of time in just looking through the standards that are available, the standards development that's available, and then arriving at a set of standards, again, following what's happening internationally. So the devices that are bought and installed in Ireland, they are going to be ones bought from an international market. So been looking at best in class around the world and what is likely to become the standard internationally, adopting that here. So we've started setting out standard requirements from our perspective for interoperability, and then, we've been setting out the standards. We're starting to work with the NSAI on the adoption of those in Ireland. So again, it's not just ESB Networks saying, hey guys, look, these are really good standards. They're becoming standards in Ireland so that people are manufacturing to them, so that wholesalers and retailers have the right devices in stock. So that again, I mentioned the plumber being the one who picked the heating system. Make sure that the plumber knows what he should be selecting. It is easy for him to select. Prices are coming down because it is standard. So the technology goes into the home. And then that's the point where you can start making things work. Because Paddy, you were talking there about diversity. The thing is, diversity can be engineered right back in. People's behaviors inherently are still quite diverse from each other. If you take my household and my next door neighbor's household, we're on the same electricity network. The diversity can be re-engineered. So we're a get up early in the morning, go out to work and school, come back late in the evening, live life in about an hour, and then go to bed. Whereas my next door neighbor is around during the day. She's in and out. She's heating the home. She's charging her car. She's driving her car, not very far. So if we put solar panels on the roof, again, if that is a smart inverter, if somebody is managing that smart inverter, they can identify that, look, in our area, on the days when it's sunny and my household is out, along with half the households in the neighborhood, it's my next door neighbor on the other half who could and should be consuming that, charging their cars, heating it, so effectively storing it. And then in the evening, things swap around and we suddenly have a peak where the rest of us arrive home. Well, no, push out that peak, use some of what has been stored during the day to support the rest of us in the area. But it only works. It only works when all of us getting on with living our lives happen to have the right technologies installed, and expecting us all to know precisely what to get. That's not going to happen. One of the women working for me, she's an engineer, married to an engineer with 2 children who are both engineers. They got 2 electric cars recently, and they wanted to be good electricity citizens. So they wanted to get the right technology. And they had a lot of work to do to find smart chargers and work out what was reasonably standardized. And then once they had them, they caught that their smart charger wouldn't talk to their car because their car also had smarts installed, and the smarts in the 2 of them were getting a bit confused. So, we can't count on everybody having a family of engineers, and we certainly can't count on it working if the family of engineers can't get it working. We need to get the standards in, to get the standards right. We also need to make sure that when, again, we're supporting technologies, so the SEAI providing the grant funding, that the grant funding is being provided for the technologies that are smarter, that are compliant with the standards, which are going to be the interoperability standards. That is something, though, that everybody's got in their mind. So the SEAI, I know, are working towards now having smart standards ingrained into what is grant supported. So we are going to get there. But again, it takes us, ESB Networks, setting out, here's what we're going to be interoperable with. The NSEI saying, right, okay, here's what in Ireland industry and manufacturers need to be interoperable with. The SEAI saying, okay, that's a set of standards we're going to support. You guys getting out there and saying, grand, okay, so it's 2030.5 and building your own systems, your own APIs to talk to that. So,
I think that's exactly where I think it needs to go. And that's where I think that perhaps some of the sentiment analysis can sometimes fall down, because to paraphrase, I think it was a former Sony CEO who said that if you design based on asking people what they want, you'll never shape the future. You need to design what you believe is going to be acceptable in 10 years' time. And I think that's important. And so in terms of, my view of where this is going to go at the customer level, I think technologies that have been successful in the past have been ones that have been seamless. And a lot of what we talk about in terms of the future participation by the consumer in the grid, I think would worry people. Am I going to have to add more things to my day that I need to do to manage my participation here? Whereas I think the reality is that this is going to be seamless. And in the same way as you go to Harvey Norman to buy a dishwasher now and it's, A++ compliant, you'll go and you'll find your smart grid compliant, and it will connect based on one of the interoperability standards that you guys have set out. It will connect to the home. And from the customer's point of view, the only change will be is that with that dishwasher, instead of telling it when to start, you tell it when to finish. And then it will optimize with the electricity system and potentially make you money and certainly get you credit against your electricity bill. Similarly with your heating system, you give it a band in which to operate in terms of heat, it'll optimize itself. And then in terms of your electric car, don't tell it when to start, tell it when to finish as well. And I think this only works if it's that seamless. And from a cost point of view, it's essential that with the interoperability standards, that then gives incentives to the device manufacturers, because who wouldn't want the device that makes the money? This dishwasher makes me money, that one doesn't. Who wouldn't want that? So I think it's really a case of that the only approach that can viably be taken at that tier is they build it and they will come.
Well, the one thing I'd throw in, Paddy, is not everyone goes to Harvey Norman. So we do need, again, to make sure that this gets in the level where it is accessible to everybody. So things like building regulations, that the building regulations require certain devices, it requires certain standards to be complied with. When you bring that together with work that the local authorities are doing, that's how you ensure that this is accessible to absolutely everybody. Because I'd agree with you, that picture of seamless in the future, that is where we need to get to. But yes, absolutely, we can set out standards. We can push out commercial signals saying that, yes, there will be money for this. But again, we need to cover all of the bases. So building regulations, local authorities, make sure that all of the supports are pointing the one direction. Because, I also believe we will get to a point where the smart technology is there, can be coordinated again by companies like your own, like others, who take that information and manage the technology. But equally, I think to get there, we do need to make this more of an open and societal push. The one that to me always rings of, yes, we can bring about change is the recycling. So I grew up in a household where there was one bin and everything went into that one bin. Now I go to that same household and I'm still working out which one of my parents' bins is the one that I'm allowed to use. My kids know though. My kids can tell me, oh, that's the one, Mammy, that's what did you put in there? And we do, we've gotten to that point with recycling because everything has come together. The kids are intercepted in school and told, here's how it works. And it's just natural to them. The bins were provided, they are a certain way. Yes, the pricing signals are there. So it is much, much cheaper for me to get rid of my brown bin or my green bin than it is my black bin. So you need to have all of those signals there. And I hope and I believe that in 10 years' time, it will just be implicit and natural and there. But to get there, we need to focus on bringing together regulatory, technical, educational awareness, bringing together all of those things for this to actually happen.
And I think that's where the task lies with us, is to bring all of that together and ultimately make it a seamless journey for the customer. It's been really fascinating chatting about this. There's so much about to happen. We think that it's been an exciting decade just gone in terms of demand response and what's happening with the amounts of industrial customers providing, but I think it's going to be absolutely minuscule in contrast to what we're going to achieve over the next decade. So, Jon, Ellen, thank you very much. It's been great to talk to you.
You too.
Thank you.